Ever wondered about the concept of limit speed in aviation? What does it mean and why is it so crucial? Well, let's dive into it. Imagine you're in a plane, soaring through the skies. The airflow around your plane's wings, or any lifting surface for that matter, changes as the angle of attack increases. The angle of attack, by the way, is the angle between the wing's chord line and the oncoming airflow. For most flying conditions, this airflow is smooth and laminar, and Bernoulli's theorem applies. The theorem states that an increase in the speed of the airflow results in a decrease in static pressure. This increased speed of the airflow, particularly over the top of the wings, leads to lower static pressure, and voila, lift is generated. But there's also drag or resistance to forward motion. The lift capacity or lift coefficient of the wing increases as the angle of attack increases, but only up to a certain point. This point is called the critical angle. Beyond this critical angle, the airflow starts to separate from the wing surface and becomes turbulent. When this turbulence becomes significant enough, we hit what's known as the limit speed. The limit speed is the speed at which this significant change from laminar flow to turbulence occurs over a wing. The lift coefficient reaches its maximum at this speed and decreases noticeably beyond it. As the angle of attack continues to increase, the center of pressure, which has been gradually moving forward, suddenly moves back, and there's a rapid increase in drag. So, the limit speed occurs at the critical angle of attack. It's a crucial concept in aviation, as it's the speed at which the aircraft's lift starts to decrease, potentially leading to a loss of control. Understanding and recognizing the limit speed is key to safe and effective flying. Stay tuned as we delve deeper into the critical angle and limit speed in the next scene. Now that we understand the basic concept of limit speed, let's delve into the critical angle and its relation to the limit speed. The critical angle of attack is a pivotal concept in the dynamics of flight. This is the angle at which the lift capacity of a wing, also known as the lift coefficient or CZ, reaches its maximum value. However, beyond this angle, the lift capacity significantly decreases. This decrease in lift capacity is largely due to the change in airflow around the wing. Under normal conditions, the airflow around a wing is laminar, meaning it flows smoothly and continuously. However, as the angle of attack increases, this laminar flow starts to become disrupted, transforming into turbulent flow. This turbulence then disrupts the creation of low-pressure zones on the upper surface of the wing, which are the primary generators of lift. As the angle of attack continues to increase and reaches the critical angle, the point of flow separation on the wing shifts abruptly forward, causing a significant increase in turbulence above the wing. The disruption to the laminar flow becomes so severe that the wing's lift capacity significantly decreases. This critical angle is also where the limit speed occurs. The limit speed is the speed at which there is a significant change from laminar to turbulent flow above a wing. Beyond this point, the center of pressure, which gradually moves forward as the angle of attack increases, suddenly shifts back, resulting in a rapid increase in drag. The critical angle or limit speed angle is where CZ reaches its maximum value, and beyond which Cz evidently decreases. Beyond the limit speed angle, the aircraft experiences a dramatic increase in drag and a sudden drop in lift, making it harder to control and potentially leading to a stall. This critical angle and limit speed connection is vital in maintaining control and stability during flight. It's a delicate balance that pilots need to master to ensure safe and efficient flight operations. Being able to recognize the limit speed is essential for pilots. But how can they do this? Let's dive right in. As an airplane nears the limit speed angle, there are distinct signs that pilots can detect. One of the most noticeable is a phenomenon often referred to as vibrations or control flutter. This occurs when the laminar air current starts to break down and divide across different parts of the wing. As the turbulent air flows back over the tail of the aircraft, it causes the fuselage and the controls to vibrate. This isn't just a random shudder, it's a warning sign, a telltale signal that the aircraft is nearing its limit speed. But that's not all. Another profound change happens when reaching the limit speed. The airplane starts to pitch down. This is due to a decrease in lift, which is the force that keeps the plane airborne. Remember, as the limit speed is approached, the laminar flow over the wing decreases, reducing the low-pressure areas that generate lift. As a result, the lift drops and the nose of the aircraft dips. This downward pitch is a significant indication that the limit speed has been reached. For most training aircraft, the limit speed angle is about 15 to 16 degrees. The maximum lift occurs at this limit speed angle. However, beyond it, lift decreases sharply. This decrease is another crucial sign that pilots need to watch out for. Now you might wonder, why is all this important? Well, surpassing the limit speed can lead to a rapid increase in drag, making it much harder for the aircraft to maintain altitude and speed. Recognizing the signs of nearing the limit speed allows pilots to adjust their flight parameters in time, ensuring a smooth and safe flight. Knowing these signs can help pilots avoid surpassing the limit speed and maintain safe flight conditions. So the next time you're soaring through the skies, remember these pointers. They might just be the key to a smooth landing. But what happens if a plane reaches its limit speed? Is recovery possible? Absolutely. When an aircraft hits its limit speed, it's not the end of the flight. It's a call to action. The plane is in the limit speed flight phase, and the pilot must work to return the aircraft to normal flight. The key here is reducing the angle of attack. This is the angle between the aircraft's wing and the oncoming air. When a plane hits its limit speed, this angle has increased to a critical point. Reducing it is crucial to recovery. This reduction is achieved by moving the control column forward, but it's not a jerky, sudden motion. It's a quick, yet smooth action. A sudden move could exacerbate the situation, whereas a smooth, swift action can guide the plane back to its normal flight phase. Understanding and managing limit speed is vital to maintaining control and safety in aviation. Remember, limit speed is not just a number, it's a crucial part of flight dynamics.